Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 18. Lithium Iron Phosphate Batteries. Solar Panels, Part 3. We will continue discussing solar panels and answer the question, how do I wire the solar panels together to maximize the output of my array? The first thing to get the maximum out of your solar array is to have all your solar panels the same. Their wattage, voltages, and currents need to be matched for the best performance. A suggestion here. I would get the most common voltage and wattage solar panels there are. This will make it easier to replace if needed. In my case, I decided on 12-volt 100-watt solar panels, as I can use them for one panel to charge my car batteries or the portable LFP batteries I built. I can use two in series to directly charge my main 24-volt system, or I can use four in series to maximize my charging with smaller wiring. This is why it is important to design your system before you purchase any equipment, so you can get all your solar panels at once in the same configuration. It is easier and cheaper to change things on paper than in real life. I have provided links to a few videos that discuss what happens when you use different solar panels together. Look for those in the video description under Mixing Different Solar Panels. We'll briefly look at connecting one solar panel, two or more panels in parallel, two or more in series and parallel. Only connecting one solar panel to your charge controller will be the easiest. It will not provide enough power for a house system, but it might be fine for portable operations. Simply connect the positive of the solar panel to the positive of the charge controller's solar input and the negative of the solar panel to the negative of the controller's solar input. Remember to connect the battery to the charge controller first before connecting the solar panel. Usually, the size of the wire that comes with the solar panel will be large enough unless you need to extend its length by a lot. You will need to be very aware of the wire size from your solar panels to your charge controller so you don't use too small of a wire. Now, connecting two or more similar panels in parallel will increase the current into your charge controller, but may require a larger wire size. If you have two 5-amp solar panels and connect them in parallel, you will have 10 amps into the charge controller. You will need a special combining adapter to connect each solar panel together. To reduce the number of wire needed to go from the solar panels to your charge controller, combine the solar panels as close to the solar panels as possible. This way, you only need to run a single set of wires to your charge controller. This method is fine for 2 or 3 panels connected in parallel. However, if you try to connect more than 3 panels, you might need to run larger and more expensive wiring. If you need to have more charging power for a larger battery bank or want to charge your batteries faster, you should consider wiring your panels in series. Connecting them in series will increase the voltage, but the current will remain the same. In my main system, I have 4 100-watt 12-volt panels connected in series. Each panel produces up to 20 volts at 5 amps. That 4-panel series array can send 80 volts at 5 amps to my MPPT charge controller. Since my MPPT charge controller can accept up to 150 volts from my solar panels, this is not a problem. My wiring run is 50 feet, but because of the higher voltage, I only need a 10-gauge wire. This saved me money as I didn't need to have larger and more expensive size wiring. As we discussed in the charge controller topic, an MPPT controller can take the higher voltage and convert it into usable charging current. Here's an example of how higher voltages have fewer losses. Let's calculate the line losses of an 80-volt, 40-volt, and 20-volt solar output at 10 amps with a 50-foot distance from the solar array to the charge controller. The 80-volt loss is 1.24 volts. That's a 1.55% loss. The 40-volt loss is 1.24 volts, which is a 3.11% loss. Finally, the 20-volt loss is still only 1.24 volts. However, that is a 6.21% loss at the lower voltage. A 1.24 volt loss at 80 volts is much less than a 1.24 volt loss at 20 volts, so you lose much more of your solar power at the lower voltages than at the higher voltages. Now, if you need to have even more solar power feeding your charge controller, you might wire them in parallel series. Now back to my main solar array. I have two sets of 4 12-volt, 100-watt, 5-amp panels connected in series. Each set produces up to 80 volts at 5 amps. I wired these two sets in parallel to increase the amps from 5 amps to 10 amps. However, the voltage remains at 80 volts. This doubled my charging without having to get larger wiring. I have provided links to wire sizing calculators and a video so you can determine the size of wire you will need based on the voltage, current, and distance between the solar panels and charge controller. Look for those in the video description under wire sizing. One piece of equipment that makes connecting each set in parallel easy is a combiner box. The one I have can accept 4 sets of panels or panel sets at a maximum of 10 amps per set. Each incoming set is fused to 10 amps. Remember, my 4 panel sets are only producing 5 to 6 amps, so no problem. The combiner box connects those sets in parallel and sends that to the charge controller. In my case, I only have 2 sets connected to the combiner box, so only 10 to 12 amps are going to the charge controller, so I only need 10-gauge wiring. If I connect those 8 100-watt 12-volt panels in parallel, I would have 40 amps going through the wiring from the solar panels to the charge controller. This would require me to replace my 10-gauge wiring with 3/0-sized wiring to get only a 1.55% loss, as we did with the 80 volts at 10 amps. As you can see, this is the size of 10-gauge wire, and this is the size of a 3/0-gauge cable. This size cable would not only be too large to connect to my charge controller, but would be many times the cost than the 10-gauge wire would. As you can see, wiring your panels so they produce more voltage can make things easier in terms of the size of wiring you need and the cost. This is the reason it is very important that you design your system before buying anything. I also provide a link to a video about many of the mistakes made in installing a solar system. Look for it in the video description under Solar System Mistakes. Next week, we'll continue our All About Electricity series and discuss what protective equipment should you have for your solar battery system. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.